Namaste and welcome to Code Divinity. I am your coding friend Om and today's problem is matrix diagonal sum. This is an easy level problem, so let's get started. We will be given a 2D matrix and we have to compute the summation of both the diagonals. What does this actually mean? Let's observe that. Our task is to sum the elements from the diagonal. So diagonal elements are 5, 10, 25. This is the first diagonal. And the second diagonal is 3, 10 and 7. 5 plus 10 plus 25 and 3 plus 10 plus 7 respectively. This is equivalent to 25 plus 5 30 and 10, this is 40, and this is 7 plus 3 10 and 10 plus 10 20. But we can observe that this 10 is added twice for the first diagonal and the second diagonal as well. So after completion of the sum, we have to deduct the middle element from our entire summation. So this will provide us our answer. Now let's see the algorithm that will help us to achieve this solution. In order to solve this problem, we will be using iterative approach. Now in this iterative approach, we will iterate across this 2D matrix and we will add all the diagonal elements into our result variable. Now let's take an example of a matrix. So our first diagonal will be 0 0, 1 1 and 2 2. We will add them to receive the sum of our first diagonal. Then the second diagonal will be 0 2, 1 1 and 2 0, and this will be our summation of the second diagonal. Now we can observe that this 1 1 is repeated twice. So after having this answer 1 and answer 2, subtract this once to get our final result. When the matrix is odd sized, then we have to subtract the middle element. But in case the matrix is of even size, then we do not have to subtract the middle element because there is no middle element in that matrix. Let's see how. Consider a 2 by 2 matrix. So our first diagonal will be this one and the second diagonal will be this one. Now there is no middle element or there is no intersecting element in this case. Now let us write the algorithm for this solution. Now let's see the steps of the algorithm to solve this problem. First, we declare a result variable. This variable will store the summation of both the diagonals. Then we will start a for loop which will move from I equals to 0 and go up to size of matrix. Now within this for loop, we will perform the summation and store the value into our result variable. So for the first diagonal, our condition will be matrix of I and I. So it will be iterating over matrix number 0 0, 1 1, 2 2 and so on. Then for the second diagonal, our index will be matrix of I and then n minus I minus 1. So if our I is 0 and our n is 3, so it will be n minus I 0 then minus 1. So this will be equivalent to 0 2. Then when I becomes 1, n is 3, minus 1 and this will give us 1 1. For 2 it will give 3 minus 2 minus 1 and that will be 2 0. This portion gives us the second diagonal. After completion of this for loop, we will check if the size of matrix is even. If the matrix size is even, then it is not a problem. But if the matrix size is odd, in that case we will subtract matrix of size by 2, size by 2. This will give us the center element which has been added twice to our result variable, and we are subtracting it. Finally, fourth step is to return our result variable, and hence we have completed our problem. Now let's code it. This is the problem on LeetCode, problem number 1572, matrix diagonal sum. This is an easy level problem, and let's read the problem statement now. Problem statement states that we are given a square matrix MAT and we have to return the sum of matrix diagonals. So we can observe that we are given a 2D matrix here in our function, and we have to include the sum of all the elements on the primary diagonal and on the secondary diagonal that are not part of the primary diagonal. So they are just explaining things complicatedly. Let's simplify it. If the array size is odd in number, there will be one element in the center which is repeating in both the diagonals, so we have to remove it. But in case of an even sized array, there is no intersecting elements, so there is not a necessity to deduct anything. Now the problem statement is clear to us. We can start coding our solution. So we will first compute the size of our matrix, and we will get it from the size function. Then we will declare a result variable which will store the summation of both the diagonals. Then we will start a for loop which will go from 0 to size n, and then we will increment the pointer. Then to get the value from the first diagonal, we will go to the II index. This will give us 0 0, 1 1, 2 2 and so on. So we can see that this is giving us the first diagonal of our matrix. Now we have to add it with our second diagonal, and to get the second diagonal we will fix the first index as I and second index as n minus I minus 1. So let's check if this index is actually providing us our second diagonal or not. If I is 0, then our n size is 3 minus 0 minus 1, and 3 minus 0 minus 1 is 2. So our first index is 0 2. When I becomes 1, n is 3 minus 1. So this will give us 1, and similarly we will get 2 0 and so on. So we can observe that we are getting our second diagonal with this indices. Now we have to add it with our result variable to store all the summation. Then when this for loop is completed, we will check if our array size is even or odd. If n modulo 2 is true, then we will deduct the intersecting element or the middle element which is common in both the diagonals. In order to get that element, we will take the indices n by 2 and n by 2. This will give us the central element, and after deducting it once, we will get our final answer. So we will return it to the console back, and our solution is completed here. So now let's run it and check on the test cases. So it is running successfully, as it is demanding the summation 25 and our solution is also giving 25. Now let's submit this test case and check if it is working on all the test cases or not. So as you can see that our solution is working on all the test cases, and it beats about 14.49% of solution. So I hope you like the solution. If you have any more suggestions, please write in the comments below. Do like the video if you like my way of explaining, and I will meet you in the next one with another solution, and there are many more solutions coming forward.